how do we write the equation of an ellipse given the graph? Let's use this checklist to help us find that solution. So if I were to draw in the major and minor axes, where they intersect will give us the center. So the center of this ellipse is at -3, -1. We can also figure out the A and the B value. Since this is longer vertically, that is 4 units for the A, and the B is 1 unit from the center, left and right. We'll deal with C later because C helps us find the foci. Now the major axis, well, we could see it stretching vertically. What that's going to mean in a moment is the A value needs to be under the Y's when we write the equation. Okay, so I tend to write the equation as something plus something equals 1. And I just fill in those pieces. I know that the ellipses equal 1. This is a plus between the two fractions. It's x something being squared, y something being squared. Okay, so take the center, -3, -1. So we have x plus 3, and we have y plus 1 in the numerators. And in the denominator, the y gets the a because it's stretched vertically. So this is going to be 4 squared, and x's get the 1 and square it. So our final solution is x plus 3 quantity squared over 1 plus y plus 1 quantity squared over 16, and that equals 1. Now to find the foci. Okay, we can estimate them. I know they're going to be somewhere above and below the center. So I'm going to do some side math up here. So c squared equals a squared minus b squared. So c squared is equal to 16 minus 1. C squared equals 15. C is equal to the square root of 15, which is about 3.87. So we have the center -3, -1. I'm going to add 3.87 to the y values to go up and down. And so therefore the final solution is -3, 2.87 and -3, -4.87. And those are our answers for the foci. And do those seem reasonable? Let's see, 2.87, yep. And down here. Do double check. I have had students in the past who will find foci and the foci end up being outside the ellipse. So just double check to make sure your answer makes sense. Is it reasonable? Okay, one more example. Okay, looking here at this. Now, we've gotten some different clues this time. I see the foci, you got those clues. We've got the endpoints of the major axis, but I did not indicate exactly where the endpoints of the minor axis are. So we kind of have an issue with that. We do see the axes though. Okay, since the foci are vertically oriented, then our major axis is vertical. So I know that when I write my equation in a moment, the a value is going to go underneath the y fraction. Okay, because it's stretched vertically. Let's see, the center must be 0, 0. Okay, so the a value, well, we go up to 6. So the a is 6, which means in my equation for the y's, I'm going to put 36 down below. I'm going to square that a and write 36. Okay, we know the b, we don't know the b value, because I could estimate the b is probably about 5 point something, but I'm not sure what. But I do have a clue. I know the foci. So the foci are 3 units from the center, and I'll use that to solve for b. I don't have to do a lot of calculations for the foci because literally we are given it. So the foci are 0, +3, and -3. So I'll shortcut that and just write 0 plus or minus 3. Oh, yay, we got one answer done for sure. Okay, so let's use the formula c squared equals a squared minus b squared, and we're going to solve for the b value. Okay, so c is 9. C squared, excuse me, is 9. A squared is 36. Okay, and we just solve for b squared. So subtract 36, we get negative 27. Divide both sides by negative 1, we get 27. So 27 equals b squared. Now I could square root, but, well, let's go and do it to get the b value. So b is equal to the square root of 27, or approximately 5.20. And does that seem reasonable? Yeah, it's a little bit more than 5 from the center, so about 5.20. But I don't need the 5.20 or the square root of 27. B squared is 27. We'll put that in the equation. Okay, so let's fill in the numerator. Well, lucky us, the center is 0, 0, so all I need to write is x squared and y squared. So our final solution is x squared over 27 plus y squared over 36 equals 1.